This is class 18 of my arithmetic course. Today you're going to be learning about decimals. Now the most important thing to understand about a decimal is that it's just a fraction. But it's a special type of fraction. A lot of people think that decimals are something different from fractions, but no, decimals, again, they're just fractions. And another important thing to understand is that a decimal is an abbreviated form of a fraction. So that's the two most important things to understand. A decimal is a fraction, and it's also an abbreviated form of a fraction. So here's a decimal, and as you can see, it's just a bunch of numbers with a dot next to it. This is what the decimal actually means. Okay. As you can see, a decimal is a sum of fractions. This is what it actually is. But this is the abbreviated form. We don't write all these denominators, and we don't write it as a sum. We just write a bunch of numbers with a dot next to it. Now, it's also important to understand that this 0 here is only written so that we can see the decimal better. If we just wrote 0.754031, we might think that this decimal is just a speck of dirt or something, and we might accidentally interpret it as 754,031. So that's why we write that extra decimal there, or that extra 0, so that we can just see the decimal better. You would never write 0.754031 because that's a leading 0. That's not a number. So when people see this 0, they know, oh, there must be a decimal there, or else the writer wouldn't put that 0 there. So that's what a decimal is. It's just a sum of fractions. But these fractions are not just any fraction. And by the way, we're going to learn how to add all these fractions up and write this decimal as one fraction. So we're not going to be writing all this stuff. But it's important that you understand what the decimal actually is before we put it in a more condensed form. So notice these denominators, they have very special numbers. It's just a 1 with a bunch of zeros. So these denominators are called powers of 10. If you take 10 and multiply it by itself, you get 100. If you multiply it by another 10, you get 1,000. Remember, we learned power notation when we were doing factor trees. 10 to the second power just means 10 times 10, which is 100. 10 to the third power just means 10 times 10 times 10, which is 1,000. And 10 to the fourth power means 10 times 10 times, I think you get the point. So that's why these denominators are called powers of 10. Now the big question is, why are we writing this decimal? Why do we write fractions with powers of 10? Why do we care about this? Decimals are a huge part of life, and they're a huge part of your academic curriculum and the math curriculum. So why do we even bother to write decimals? Well, it goes back to what I was talking about in class number 2. Our entire number system is based on 10. We have 10 fingers. We use our 10 fingers to count. Our language is based on 10, so fractions that are written in decimal form are easier to work with when we're doing calculations. That's why we use decimals. It just makes things easier. That's your introduction to decimals. That's pretty much what it all means. And that's why the 7 is said to be in the 10ths place. Because when the 7 is written in this place, it's considered to be 7 over 10. And the 5 is considered to be in the 100ths place. And we write it as 5 over 100. And so on and so forth. So in previous courses, we learned 1's place, 10's place, 100's place, so on and so forth. That's to the right of the decimal. When you write to the right of the decimal, you just write a plural s. But that's to the left of the decimal, not to the right. When you write to the left of the decimal, you get plural s. But when you say the names or the places to the right of the decimal, then you use THS. Instead of just s, you use THS. That's just the way it's done. Also, an important thing to understand is that when you name the places to the left of the decimal, you start with 1. But when you start naming places to the right of the decimal, you don't start with 1. You don't say 1th. You say 10ths. And the reason for that is that if you said 7 out of 1, that would just be 7 wholes, and that would be in the ones place. So it doesn't make sense to write, again, these numbers are all fractions. So it doesn't make sense to say 7 over 1 because that would go in the ones place. So we start with 10. It's 7 tenths, 5 hundredths, 4 thousandths, so on and so forth. Also, I didn't mention that the word decimal has the word dec in it. Okay, that word dec means 10. The month of December used to be the 10th month. It's not the 10th month anymore, and it's a long story about why it's not the 10th month. But that's what December used to mean. Used to be the 10th month. The word decade means 10 years. It has the root word DEC in it. Decagon is a shape with 10 sides. A deck of cards is numbered up to 10. That's the highest number, so they call it a deck of cards. So that's where the word comes from. So anyway, at this point, you're going to have to learn these place values. And you just keep multiplying by 10 each time you go one place value to the right, just like we multiply by 10 when you go one place value to the left. All right, so I think that's it for the introduction for decimals. Now let's do some practice problems. The rest of this course is really this class is just going to be converting back and forth between decimals and fractions. Now I'm telling you that we're converting from decimals to fractions, but that's not really a technically correct statement because a decimal is a fraction. So just be aware that when I say convert from a decimal to a fraction, I'm not saying that decimals are different from fractions. We're just going from one form of a fraction to another form. All right, so let's get into it. Number 1, convert the following decimals to fraction form. So the 7 is in the tenths place. So we write 7 over 10. Easy. Just like this 7 up here was in the tenths place. Now down here, the 2 is in the hundredths place. So we write over 100. And we can actually reduce that. If we divide both sides by 2, we get 1 over 50. And down here, the 8 is in the tenths, hundredths, thousandths, 10 thousandths. So it'd be 8 over 10,000. And if you divide both sides by 2, you get 4 over 5,000. And you divide both sides by 2 again, you get 2 over 2,500. And you divide both sides by 2 again, you get 1 over 1,250. Now you could have gotten there faster if you divided by the greatest common factor, which I think would be 8. If you divide both sides by 8, you could have gotten there faster. But learning how to reduce, this is not really the purpose of this course or this class. So don't worry about that. So again, you have to find what place the number's in, and then just write that number over whatever that place is. So why don't you try numbers 4 through 6, pause the video, and when you come back, we'll do them together. All right, we're back. Point 3 is 3 over 10. 0.005 is 5 over 1,000. Now that can be reduced. If you divide both sides by 5, you get 1 over 200. And the 4, that's in tenths, hundredths, thousandths, 10,000, 100,000, millionths. I guess it's in the millionths place. Divide both sides by 4, and you get 1 over 250,000. So if you got those correct, pat yourself on the back. Remember to rectangle all your answers. If you got 4 over 4 millionths on that one, it's correct. It's just not reduced. All right, number 7. Now, number 7, we have something different. In the previous problems, we just had one number, but now we have 3 numbers. How do we deal with this? Well, again, you have to go to the expanded form. Whenever you write a decimal, you're just writing technically a sum of fractions. But we don't want to write the decimal as a sum of fractions. We want to write it as just one fraction, but we can easily get a common denominator here. And that's one of the reasons that decimals are used, is because it's so easy to find a common denominator. So we can find a common denominator and just add those fractions up. And we're going to learn a fast way to convert this into a fraction. But right now I'm going to show you the slow way, just to demonstrate the principle here. Because again, the most important thing is to understand decimals. If you can convert back and forth from a fraction to a decimal, and later on we're going to learn how to convert to percents, that's great. But if you don't really understand what a decimal is, it's going to cause problems in the future. So let's write this in what we can call expanded form. So 0.851 is the same thing as 8/10 plus 5 100ths plus 1 1,000ths. And you can say 1 1,000ths or 1,000ths. It's probably better to just say 1,000ths or 500ths, 8/10, so on and so forth. So again, we just wrote it in expanded form. This is an abbreviated form of the fraction, but this is what it actually is. So at this point, we can then get a common denominator. If we multiply both sides of this fraction by 100, we get 800 over 1,000. And if we multiply both sides of this fraction by 10, we get 50 over 1,000. And you can see where I'm going with this. Now we have a common denominator. So we can add all those up, and we get 851 thousandths, or 851 over 1,000. You can say it either way. All right, so there's an extremely important principle here. Notice that the number farthest to the right, that's in the thousandths place, tenths, hundredths, thousandths. And notice that our fraction, when we combined all these fractions, our resulting fraction had thousandth in the denominator, the same number that the place of the number farthest to the right in our decimal is named after. So that's the fast way to change 0.851 into one fraction, to condense all these fractions into one fraction. So we're going to use that fast way to convert decimals to fractions for now on. For example, 0.7132 would just be 7,132 over 10,000, because the 2, the number farthest to the right, is in the 10,000ths place. So this is very easy. But again, if you write this in expanded form like we did here and get a common denominator, you can see why that method works. But 99.9999% of people that use decimals, they never think of decimals in this way, and they never think of it to the extent that they actually forget that decimals are just fractions. They're just a sum of fractions. Very few people understand that decimals are really just a sum of fractions. All right, let's try 0.21. In fact, why don't you go ahead and attempt numbers 9 through 11, and when you come back, we'll do them together. All right, we're back. 21 over 100, because 1 is in the 100th place. 351,888 over a million, because the last number to the right is in the millionth place. And we have 98,903 over the tenths, hundredths, thousandths, 10,000ths, 100,000ths place. I have to count 100,000ths. And of course, remember to rectangle your answers. Also, I didn't mention that you can actually reduce this number, but I'm not reducing that. And the reason I'm not reducing it is because it would just be too laborious. I'm not going to force you to reduce that. You can reduce this fraction also, but that would just take too long, and it's not really the point of this class. All right, so now we're going to go on to something a little bit different, but pretty much the same thing. The difference with this number is that we have two leading zeros. They're called leading zeros. Those leading zeros, they don't really have a value other than just, 0. So they're really just serving as placeholders. So let me show you what I mean. So let's write this at decimal in expanded form. That means 0 tenths. That's this number. And then we have 0 100ths, which is this number. And then we go into the actual numbers that have value. 3 1,000ths plus 5 10,000ths, and so on and so forth. But the important thing here, that what I want to demonstrate, is that these zeros, they don't have place value, and we haven't really talked about this yet. But when you have 0 in the numerator of a fraction, it's like if you have a pizza that's cut into 10 parts, right? I know most pizzas are cut into 8 parts, but let's just assume a pizza is cut into 10 parts, and you're having a party, and everybody takes the pieces. They take them all away. They're gone. So you have 0 out of 10. So what is 0 out of 10? It's just 0. So you can consider 0 out of 10 to just be 0. And 0 out of 100 is 0. So those are, you can just ignore those. So then you have 3 1,000ths plus 5 10,000ths, and so on and so forth. And when you add all these numbers up, when you add all these numbers up, you're just going to get 3,506. Even though the sixth is in the tenths, hundredths, thousandths, 10,000s, 100,000s, even though the 6 is in the millionths place, this number is only going to be 3,506 because these numbers are just zeros. It would be, if these numbers had value, it would be, let's say that these two zeros were like 7 and 8, then it would be 783,506. It'd be much a bigger fraction. But because those zeros are just 0, we only have 3,506. So again, do most people think about that when they're doing this math? Not really. But just be aware, those are called leading zeros. So this is going to be 3,506 over 1 million. And you can reduce this fraction, but again, I'm not going to make you do that because it would take a long time. So here we have 91 over, the 1 is the last digit to the right, is in the thousandths place. And why don't you try numbers 14 all the way to 18. And when you come back, we'll do those together. All right, we're back. 151 over a million. $7,009 over, let's see, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths. It's actually 100 millionths. Then we have 705 over 10,000. And we have 513 over 100,000. And 63 over 100,000. All right. So again, these are called leading zeros. But again, it's just the same. It's the same principle. Those problems really weren't that much different from the problems before number 14. Now we have something that I call ending zeros. These zeros are to the right of the number 3. So now if we write this in expanded form, we have 3/10 plus 0 1/100 plus 0 1,000, so on and so forth. But again, whenever you have 0 in the numerator, that just means that these numbers are 0. So all these numbers, all these zeros, they don't really affect anything. You're just left with 3/10. So all that added together equals 3/10. But remember, 3/10 is just 0.3. You put the 3 in the 10th place. So the point is, all these zeros, they don't really do anything. You can just leave them off. So the answer is, you could write 3,000 over tenths, hundredths, thousandths, 10,000ths. But if you divide both sides by 1,000, you just get 3/10. So just be aware of that. These ending zeros, they don't really affect anything. So you can just make them disappear and write it as 0.3, and then write the final answer as 3/10. Now, I'm violating my cardinal rule. You always write down or to the right, so I'm going to go ahead and change that equal sign and put the final answer over here, just so I don't violate the rule. Remember, you always read left to right and top to bottom. Okay, so let's reduce the size of this a little bit. All right, so again, we have an ending 0, so we can just kind of ignore that 0, and we can just say 5,608. Instead of saying 56,080, we just say 5,608, and then we consider this number to be the last number, and that number is in the tenths, hundredths, thousandths, 10,000ths place. Now you can actually reduce this fraction further, but we're not going to do that because it would just take too much energy and time, and that's not what this class is about. So why don't you try the next two problems? Again, the denominator is going to be the number that is what this place is named after. So this place is the tenths, hundredths, and thousandths place. We don't care about these zeros because these are ending zeros. So you can just get rid of those. So try 21 and 22, and when you come back, we'll do them together. All right. So now we have 7 in the tenths, hundredths, thousandths place. And we can ignore these zeros, and we can just consider the 4. The 4 is in the tenths, hundredths, thousandths, 10,000ths place. So 804 over 10,000. So again, we can reduce this fraction. 7 over 1,000 we couldn't reduce, but 804 over 10,000 we could reduce that, but it's not really worth our time at this point. All right, so 23. Now we're going to be going the opposite direction. We're going to convert fractions to decimals. In all the previous problems, we converted decimals to fractions, but we have to go the other way too. So this is 7/10. Because we have 10 in the denominator, this is going to be really easy to convert to a decimal. We just write the 7 in the 10ths place, and we're done. Again, you can go back to your chart, or you can find one of these place value charts on the internet. There's tons of them on the internet. And refer back to that. So now we have 700 in the denominator, so we write the 7 in the hundredths place. 0.7 is not the same thing as 0.07. So now we have 89, and we have 89 over 100,000. 100,000 is a power of 10, so this is going to be pretty easy. So we need 100,000. 0.10ths, hundredths, thousandths, 10,000ths is going to be the 8, and then 9 is in the 100,000ths. So the 9 is the last digit, and it's in the tenths, hundredths, thousandths, 10,000ths, 100,000ths. So that works. All right, 756. We're going to write our 756, and we have millionths, which is also a power of 10. So this needs to be in millionths. So if we go backwards, it's kind of hard to go backwards, but millionths, 100,000ths, 10,000ths, thousandths, hundredths, tenths. I believe I did that right. Let me get my eraser out. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. Yeah, that worked. All right, 894 over 1,000. So now we put 894, and the 4 should be in the thousandths place. And if we put our decimal there, you can see it works out. Tenths, hundredths, thousandths. So you're going to get used to this as you look at the place value chart. All right, so I want you to try problems 28 through to 33. 28 through 33. Pause the video, and when you come back, we'll do them together. All right, we're back. The 9 should be in the 10,000ths place. And in 29, the 9 should be in the 10th place, which is 1 over from the decimal. And here we have 73. The 3, the last number to the right, should be in the 10,000th place. Tenths, hundredths, thousandths, 10,000ths. And number 31, 229, the 9 should be in the 10 millionths place. So we're going to need a lot of zeros here. I don't know how many. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. Well, I got lucky on that one. I guess that's the correct number of zeros. But again, it's traditional to write an extra 0 there, just so we can see the decimal better. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. Just double checking that. 100,000ths, that would just put our decimal there. The 9 is in the 100,000ths place. Again, the last digit to the right needs to be in the proper place, and we know the place by the denominator. Whoops. We don't need a comma there. And our decimal goes here because the 0 is in the needs to be in the millionths place. But remember, we have a leading 0 there, so you can actually just get rid of that 0 if you wanted to, but we're going to leave it for now. And again, we could reduce this. We could, these zeros would cancel out if we divide by 10. But again, you don't have to worry about that now. All right, so tenths, hundredths, thousandths, 10,000ths, 100,000s, millionths. That works out. All right, number 34. Now this problem is going to be different because we don't have a fraction with powers of 10 in the denominator. So how do we convert 2/5 to a decimal? Well, the way that we convert 2/5 to a decimal is we multiply both sides by 2 to get 4/10, and now we have a fraction with a power of 10 in the denominator. So now, because we have 10 in the denominator, we can write it as a decimal with 4 in the 10th place because we have 10 in the denominator. So that was pretty easy. But these problems are going to get a lot harder. This was just an easy type. It's going to get to the point where it's really not that easy to change the decimals, but we'll see. We'll come to that road when we come to it. So now, if we multiply this fraction, both sides of this fraction, by 4, we get 44 over 100. Now we have a power of 10 in the denominator. So we can change that to 0.44 because the last number to the right should be in the 100th place, and it is. So this one was a little bit harder than this one, but now we've got something that's really going to be difficult to convert to a decimal, because we have to multiply 8 by something to get 10, but we can't do that. 8 doesn't go into 10. And we can't multiply anything. We can't multiply 8 by anything to get to 100 either. That doesn't work. But 8 does go into 1,000. So we can again, we're looking for denominators that are powers of 10. So we need to change 8 so that it becomes 1,000, you see. So what do we multiply 8 by to get 1,000? Well, that's not very easy to figure out. But it turns out that you're going to multiply both sides by 125. Now, how did I figure that out? Well, I've done these problems before, so I knew it was going to be 125. But if you wanted to actually figure that out, you would just divide 1,000 by 8. Because when you divide 1,000 by 8, you're trying to figure out how many times does 8 go into 1,000. In other words, 8 times what number is 1,000? That's what we're looking for, 125. What number times 8 equals 1,000? So 8 goes into 10 one time. Remainder 2, bring down to 0. 8 goes into 20 2 times, 16, blah, blah, blah. And it ends up being 125. So that's how you would actually figure out that number. But we don't want to do that every time. We're going to learn a faster way to do this, but I'm just showing you why we have to learn the faster way to do this, because sometimes it gets fairly difficult. So 8 times 125, of course, is 1,000. And 5 times 125 is 625. So there we have our fraction, which can be reduced, but I'm not going to make you reduce that. So again, the whole point here is that this one was not easy to do. And converting fractions to decimals gets even harder. So what we're going to have to do is we're going to have to learn a sophisticated algorithm to convert fractions to decimals. But the good news is you already know what the algorithm is. In fact, we just used it down here. It's the long division algorithm. So no big deal. You're just going to be using the same algorithm you learned before. Now I just want to say, before we go into this algorithm, I just want to say that I'm not going to talk about where the algorithm comes from or why it works, because you're not really required to know that. And I think when it comes to actually explaining algorithms and where they come from, this algorithm would probably be the most difficult algorithm to explain. And if I chose 100 K-12 math teachers, just randomly chose 100, and asked them to explain why the algorithm works without using advanced mathematics, I would be absolutely shocked if 1 out of 100 could explain it. And, it's not that it's difficult to explain, it's just that it's something that you have to really think about, and you have to use geometric arguments. Remember, when you're trying to prove anything involving fractions, you have to use geometry. So it would take a lot of sophisticated geometric arguments, and you're perfectly capable of understanding it, and everybody's capable of understanding it, but it would take a lot of energy. And the bottom line is you're not gonna be required to know this. Students don't know this, teachers don't know this, so we're not going to go into the meaning of it. You're just not required to know it. Let's go ahead and learn the algorithm. So the way we're going to convert 5/8 to and we already converted 5/8 to 625 over 1,000. You know, I just realized I forgot to change this to a decimal. 625, because we have a power of 10 in the denominator, that's 1,000, so we just write 0.625, and 5 is in the thousandths place. So sorry about that, we forgot to convert that to a decimal. All right. So 5/8, we're going to, in order to convert this to a decimal, we're going to take 5, the numerator, and divide by 8, the denominator. And maybe I should move this down a little bit. So as you can see, it's the long division algorithm. You've already done this algorithm. Okay, the difference is 8 doesn't go into 5. So we're going to put a decimal, and if we consider 5 to be a whole number, then the decimal is always written to the right of the number. That's what you're going to find out. So 8 doesn't go into 5, but we're going to put a decimal, and then we're going to add a 0. Now 8 goes into 50 6 times. 8 times 6 is 48. 50 minus 48 is 2. Then we're going to bring down another 0. And usually at this point you would stop because there's no more zeros, right? There really wasn't a 0 there. There wasn't a 0 there either. But there's no more zeros to bring down, so usually you would stop. But in this algorithm, we're not going to stop dividing until we have a remainder of 0. So we're going to actually put extra zeros here. We're going to bring down another 0. So how many times does 8 go into 20? 2 times. And notice how I put the 6 above the 0. I didn't put it above the 5. That's extremely important. I'm dividing 8 into 50, so I have to put the 6 above the last digit of the number I'm dividing into. If you put it over here, you're going to get the wrong answer. So 8 goes into 20 2 times. 8 times 2 is 16. 20 minus 16 is 4. You can put your subtraction signs if you want. Now, again, we usually would stop, but we still have a remainder, so we have to keep going. Bring down the 0. 8 goes into 40 5 times. 8 times 5 is 40. And now we have a remainder of 0, which means we're done. But there's one last thing. We have to take this decimal, and we have to bring it straight up. It's extremely important to remember that. Bring the decimal straight up, and there you have it. Because we have a remainder of 0, we now are done. We converted 5/8 to 0.625. So let's write a 0 in front of the decimal so we can see the decimal better. And notice we had the same answer as 36. We just got there a lot faster than having to divide 1,000 by 8 to find this number that we multiply both sides of the fraction by, which ended up being 125 in that example. So 38, let's do another one together. Take the numerator and divide by the denominator. Now 5 cannot go into 4, so we have to add a decimal and a 0. 5 does go into 40. It goes in 8 times, and the 8 goes above the 0. It must go above the last digit of the number we're dividing into. Don't put it above the 4. 5 times 8 is 40. And as you can see, we already have a remainder of 0. So we're done. We just have to bring the decimal straight up. If you don't bring the decimal up, then our answer is 8, but that's stupid. 4/5 is not equal to 8. 4/5 is not equal to 8 wholes. So don't leave the number as 8. Bring the decimal straight up, so we get 0.8. So 4/5 equals 0.8. All right. Why don't you try 39 and 40, and when you come back, we'll do those together. All right, we're back. Take the numerator, divide by the denominator. We can't divide 4 into 3, so we have to add a 0. 4 goes into 30 7 times. 4 times 7 is 28. 30 minus 28 is 2. So we have a remainder. We have to keep going, so add a 0 and then bring the 0 down. 4 goes into 20 5 times. and then 5 times 4 is 20 exactly, and now our remainder is 0. Bring the decimal straight up. Don't forget to do that. Bring the decimal straight up, and you have 0.75. So 3/4 in decimal form is 0.75. And 1/2. Take 1 divided by 2, the numerator divided by the denominator. 2 does not go into 1, so you have to add a 0 and a decimal. 2 goes into 10 5 times. Put the 5 above the 0, not above the 1. 2 times 5 is 10. Subtract, and you get 0. So our remainder is 0. Bring the decimal straight up. Don't forget to do that. And you have 0.5, so let's write a 0 in front of the decimal so we can see the decimal better. As you can see, 1/2 is the same thing as 0.5. Now, why is that? It's because if you multiply both sides of this fraction by 5, you get 5 over 10. 0.5 is 5/10. But again, you don't have to think about that. You just have to use this algorithm, this long division algorithm, to convert fractions to decimals. All right, why don't you try, let's see here. Why don't you try the next 4 problems, 41 through 44, and when you come back, we'll do them together. Just realize that down here we're going to have a 2-digit divisor, so those are going to be a little bit harder, but I'm sure you can do it. Pause the video, and when you come back, we'll do them together. All right, 3/8. Again, take the numerator, divide by the denominator. 8 doesn't go into 3, so we have to add a 0. 8 goes into 30 3 times, which is 24. 30 minus 24 is 6. We have a remainder. We have to bring down our 0. 8 goes into 60 7 times. 8 times 7 is 56. 60 minus 56 is 4. Add a 0, bring down the 0. 8 goes into 45 times. 8 times 5 is 40. So now we have a remainder of 0, which means we're done, and we can bring up the decimal. So we have 0.75. 0.375. 0.375. And I'm going to do these without talking. I don't really think you need me to talk through this. One-fourth is the same thing as 0.25. So if you got those right, pat yourself on the back. Now these are going to be a little harder. 16 doesn't go into 3, so we have to add a 0. 16 goes into 3, or 16 goes into 30 one time. Notice I'm putting the 1 above the 0, not above the 3. That's extremely important. 16 times 1 is 16. Subtract 30 minus 16 is 14. And again, if you want to use the algorithms, I mean, I just did that subtraction in my head without using an algorithm, but you can borrow from the 3 and it becomes 2, and then add, and then 10 becomes 0 becomes 10. 10 minus 6 is 4. You can do all that stuff if you want, but at this point you should be pretty familiar with subtraction to the point where you can probably do that in your head, and this will go a lot faster. So now we have a remainder, but 16 doesn't go into 14. As always, we have to bring down a 0. So 16 into 140, that's going to be not easy. Let's see, 16 times 5 would be 80. And you can do this over here if you want. 16 times 7, that's going to be 112. How about 9? 16 times 9 is 144. So it looks like 8 is going to be the one. 8 times 16 is 80 plus, that'd be 124. Actually, that'd be 128. Subtract, and you get 12. So we have a remainder. We have to keep going. Bring down another 0. Now we have 16 into 120. We know 8 times is 128. So the only possible number that would work is 7. 7 times 16 is 112. 120 minus 112 is 8. We have another remainder, so we have to keep going. And then I think we're almost done here. 16 times 5 is perfectly 80. So the remainder is 0, which means we're done. So, just be aware that when you're doing long division with whole numbers, just because you have a remainder of 0 doesn't necessarily mean that you're done. If you have numbers here, if you have more numbers here, you'd have to keep going. But when we're using the long division algorithm for converting fractions to decimals, it's when the remainder is 0. That tells you when you're done. So now we have to bring the decimal straight up, and we have 0.1875. So that was a long one. 7 divided by 20. 20 doesn't go into 7. Add a 0 and a decimal. It goes in 3 times. 60. And our remainder is 0. So 7 over, bring the decimal straight up. 7 over 20 is the same thing as 0.35. So all we really did was just multiply both sides by 5 to get 35 over 100, and then we changed it to the abbreviated form, which is the decimal form. But we did it with a sophisticated algorithm. All right, so now we're on to 45. Now, these problems are going to be much, much weirder. Here we had 4 numbers. Here we had 2 numbers, but with these fractions, something strange is going to happen. You can multiply 16 by a number to get 10,000, I believe, because you have 5 is in the 10,000s place. You can multiply 20 by a number to get to 100 because the 5 is in the hundredths place. But it turns out that there's no number that you can multiply 3 by to get any power of 10. It's not going to happen. It's like trying to fit a square hole or a square peg into a round hole. It's not going to happen. So 3 is not going to fit into any power of 10. So this is what's going to be called a repeating decimal. Let me show you what I mean. We're going to use the same long division algorithm. So 2 divided by 3, add a 0. 3 goes into 20 6 times. Let me bring this down a little bit. 3 times 6 is 18. 20 minus 18 is 2. We have a remainder, so we have to keep going. Bring down the 0, and look what you have. Another 20. So 3 goes into 20. 6 times again, you get 18. 3 times 6 is 18. Subtract, you get 2. Bring down a 0 because you have a remainder. And what do you know? We have another 20. If you just keep doing this, you'll go on forever and ever and ever and ever. 3 goes into 26 times, 18. Bring down the 2. Bring down the 0. It'll just keep going forever and ever and ever. It'll never stop. So 0.6666, and it just keeps going and going. Bring your decimal straight up. Don't forget about that. And again, the reason it just keeps going is because 3 will never go into a power of 10. There's no multiple of 3 that will fit in. So this is called a repeating decimal. As you can see, it can be written as a fraction. It can be written as 2/3, but it can't be written as a decimal that has a finite number of digits. These just go on to infinity. So what we do is we can't write all of those 6s when we write our decimals. So what we do is we just write 0.6, and then we write a bar over it, which means it just keeps going on forever. This is called a repeating decimal. All right, 46. Let's try another one, and then you can try one on your own. So 5 divided by, again, take the numerator, divide by the denominator. 5 doesn't go into 5, or 9 doesn't go into 5, so you have to add a 0. 9 goes into 55 times, 45. 50 minus 45 is 5. We have a remainder, so we have to keep going. Bring down a 0, and look, we have 50 again. Goes in 5 times, 45. We have the same remainder. Bring down a 0. we have 50 again. So it just keeps going on and on and on and on. Bring the decimal straight up, and our final answer is going to be 0.5, but since the 5 just keeps going on and on and on, we write a bar, and so we say 0.5 bar. Again, those are called repeating decimals. So now I want you to try number 47 and number 48, and when you come back, we'll do them together. All right, 47. 8 divided by 9. 9 doesn't go into 8, so add a 0. 9 goes in 8 times. 9 times 8 is 72. 80 minus 72 is 8. Bring down a 0. 9 goes in 8 times. 72. We're getting the same remainder every time. So it's just a bunch of 8s. So bring your decimal straight up. 0.8, it goes on forever, so we say 0.8 bar. Take the numerator, divide by the denominator. 3 goes into 10 3 times. 9, remainder 1, bring down the 0. 3 goes into 10 3 times. 9, bring down, subtract. And as you can see, it just goes on forever, so 0.3 bar. 1/3 is the same thing as 0.3 bar. Again, there's no mystery here. You're probably thinking, well, this is strange stuff. We're going on to infinity. It's not strange at all. It just means that a round peg cannot fit into a square hole. Unless, of course, the peg is small enough to fit into it, then it fits in fine. That's kind of a dumb analogy. All right. So a little something different is going to happen on 49 and 50, but it's pretty much going to be the same thing. So let's try 49 together. 1 divided by 15. Add a decimal. But this is interesting. We added a decimal and a 0, but still 15 doesn't go in. So we're going to have to add another 0. And as you can see, there's going to be our first number is going to be here, and our decimal is going to be here. Whatever that number is, it's not going to be 0, but our number is going to go there. And then here, this we're going to have to put something here to be a placeholder. So we're actually going to put a 0 there because 15 didn't go in to 10, so we had to add a 0. So 15 goes into 100, I think, 6 times, and make sure that 6 is above the last digit of the number that we're dividing into. We're not dividing into 10, so we're not putting our number here. We're dividing into 100, so we put it here. So 15 into 100 goes 6 times. That would be 90, I believe. And 100 minus 90 is 10. So 15 doesn't, so we just bring down another, we have a remainder, so we bring down another number. And we have 15 into 100 again. So it goes 6 times. And as you can see, it's just going to keep going on and on. The difference was the number is not, we need a placeholder. So we write a 0 here. And we put the bar not over the 0, but we put it over the 6. Because the 0 doesn't repeat. It doesn't go on and on and on. It's just the 6 that goes on and on and on. So that was a slightly different problem because we started our repeating decimals in the hundredths place. 1 over. We didn't start in the tens place like the previous problems. So why don't you try number 50, and when you're done, we'll come back and do it together. All right, we're back. Take the numerator, divide by the denominator. 18 doesn't go into 1, so we have to add a 0. It still doesn't go into 10, so we have to add another 0. And 18 goes into 100, I think, 6 times. Make sure your 6 is above the 0. Actually, no, it doesn't go in 6 times. I think it goes in 5 times. And 5 times 18 is going to be, I think, 90. 100 minus 90 is 10. 18 doesn't go into 10, so bring down a 0. 18 goes into 100 again 5 times. 18 times 5 is 90, and you can see it's just going to keep repeating. But the difference is when you bring up the decimal, there's this space here. So we have to put a placeholder as 0. 0.055. Actually, the 5 just keeps repeating, so we put the bar over the 5. All right, so no big deal. Those are called repeating decimals. So now on number 51, we're going to, it's going to be the same situation, but now you're going to have a slight difference. So let's go ahead and do this one. 5 divided by 6, add a decimal. 6 goes into 50 8 times. 6 times 8 is 48. 50 minus 48 is 2. We have a remainder, so we have to bring down a 0. 6 into 20 goes 3 times. 6 times 3 is 18. So it doesn't seem to be repeating because we have two different numbers. 20 minus 18 is 2. Bring down a 0. But wait a second. Now it seems like it's repeating. 6 goes into 18 3 times, and you have another remainder of 2. So we have remainders of 20, 20, 20, 20. So now it's repeating. So the 8 didn't repeat, but the 3 did repeat. So we bring up the decimal. And so as you can see, it's the same type of thing. But now, because the 8 is not repeating, we don't put the bar above the 8. We put it above the 3. All right, so why don't you try, let's see here. Why don't you try the next 3 problems, 52 through 54, and when you come back, we'll do them together. All right, we're back. Take the numerator, divide by the denominator. 15 does not go into 11, so we have to add a 0 and a decimal. 15 goes into 110. I think 7 times. 7 times 15 is 105. 110 minus 105 is 5. But we have a remainder, so we have to keep adding a 0. So bring down the 0. 15 goes into 50 3 times. 3 times 15 is 45. Bring down a 5, and you can see that it's just going to be 33333. So bring up the decimal. 0.73, and the bar goes over the 3, not over the 7. The 7 doesn't repeat. It's only the 3 that repeats. All right, I'm just going to do this without talking because I don't want to bore you. You already did the problem, so you already have an idea of what's going on here. As you can see, it repeats. So 0.16, and only the 6 repeats, not the 1. So put the bar over the 6 only. So 12 goes into 86 times. As you can see, we have 80s here. Goes in another 6 times. It looks like the 6 is going to repeat. So this is kind of a different problem because we have 2 numbers that don't repeat, and then we have a number that does repeat. So you put the bar over the 6 and only the 6, not the 4 or the 1. All right. So in number 55, it's going to be the same situation. These are all pretty much the same types of problems, but there's going to be a slight difference. In number 55, we're going to have 2 digits that repeat. So we're going to have something like 0.32, 32, 32. So we're going to have to put the bar over the 3 and the 2. That's the only difference for these problems. So let's go ahead and try number 55 together. 2 divided by 11. 11 goes into 2, it doesn't go in at all, so you add a decimal and a 0. 11 into 20 goes 1 time, and make sure the 1 is above the 0, not above the 2. 11 times 1 is 11. 20 minus 11 is 9. We have a remainder, so we have to bring down a 0. 11 goes into 90. Let's see, 8 times. Remainder 2. And you can put your subtraction signs if you want. You don't have to put them in there every time, or else it's going to get kind of tedious. Bring down a 0. 11 goes into 20 one time. And the remainder is 9. Bring down another 0 because we still have a remainder. 11 goes into 90. We already figured that out. It's 8 times. And you have a remainder of 2. Bring down a 20. 11 goes into 20 one time. Do you see what's going on here? It just keeps repeating. 1, 8, 1, 8, 1, 8, 1, 8, 1, 8. Bring the decimal straight up. And so now we have 2 numbers that are repeating. So put the bar above both the 1 and the 8. All right, let's try 19 over 22. You can try this one on your own if you want, or you can just watch me do it, and then you can do the next 2. Actually, why don't you go ahead and try 56, pause the video, and when you come back, we'll do it together. All right, we're back. 22 doesn't go into 19, but it does go into 190. Let's see here. Let's try multiplying by maybe, if we multiply 22 by 10, we get 220. That's pretty close. I think it's probably going to be 8. That'd be 160 plus 16 is 176, I believe. 176. I think that's correct. And then when you subtract, you're going to get 14. So our remainder is less than the divisor, which means that we didn't make a mistake there, at least not that we can see. I'll go ahead and move this over. All right, so 14, we have a remainder. We got to bring down a 0. 22 goes into 140. We already know that. Now don't use everything that you've got here to do the problem. We know that 22 times 8 is already 176. So we know that it's going to be less than 8 times. 22 is going to go into 140 less than 8 times. So let's try 6 times. And if you try something and it doesn't work, no big deal. Just go back, erase, and try something else. 6 times 22 is 132. So it looks like that worked. So subtract, bring down to 0. 22 into 80 goes 3 times, I believe. 3 times 22 is 66. Remainder of 14, but I think you can see what's happening here. We had 140 already, and we have 140 again. So 22, we already know 22 goes into 140 6 times. And now we got 8, but we already had 8. So again, you can see what's going on here. Bring down a 0. And 22 goes into 80 3 times. And as you can see, the 6 and the 3 are repeating. Bring your decimal straight up. And we have 0.8. The 8 is not repeating, but the 6 and the 3 are repeating. So you put the bar over the 6 and the 3 only. Okay, we're doing good. We're almost done. I think we have maybe about 7 or 8 problems left. You're doing good if you've stuck with me so far. Now there's something different, slightly different about 57, so let's try that one. $11 into 10. 11 doesn't go into 10, so add a 0. 11 times 9 is 99. That's pretty close. Bring down a 0. 11, after you brought, this is what's different about this problem. After you brought down the 0, 11 still didn't go in. Remember what happens? If you bring down the number and it still doesn't go in, you have to put a 0 up here. All right, then you have to bring down another number, another 0. 11 goes into 100. We already found that out 9 times. 9 times 11 is 99. You get your 1. Now you bring down a 0, and after you bring it down, 11 still does not go in, you see? So because it still doesn't go in, you put a 0. Because after you brought down the 0, it still didn't go in, you put a 0. Then you bring down another 0, and as you can see, it's just going to repeat. Goes in 9 times, remainder 1, so on and so forth. Bring the decimal straight up, and you have 0.90 bar. So 909090. So why don't you try 58, and when you come back, we'll do it together. All right, we're back. All right, let's try 58. 22 into 7. Let's move this down a little bit. And as you can see, it's starting to repeat. And it looks like we have 0, bring the decimal straight up, don't forget to do that, 0.318, and the 1 and the 8 just repeat. 18, 18, 18, so on and so forth. But the 3 does not repeat. All right, so now we're going on to 59. And something different is going to happen with 59. Let's see what happens here. 11 divided into 1. So obviously 11 doesn't go into 1, so put a decimal and put a 0. But 11 still doesn't go in, so you put another 0. 11 into 100 goes 9 times. 11 times 9 is 99. 100 minus 99 is 1. And bring down the 0. When you bring down the 0, 11 still doesn't go in, so you have to put a 0. Remember, if you bring down a number and the divisor still doesn't go into the remainder, you have to add a 0. So now you bring down another 0, and it goes in 9 times. 9 times 11 is 99. You have a remainder of 1. Bring down a 0 because we have to keep going because we have a remainder. So bring down the 0, and after you bring it down, it still doesn't go in, so you have to put a 0. And then bring down another 0, goes in 9 times, and I think you can see what's happening here. You have to bring down a number, but after you bring down a number, it still doesn't go in. 11 still doesn't go in, so you have to put another 0 there, and it just keeps going on and on and on. But just be aware, there's something really important to understand here. The decimal goes straight up, and now you have nothing here in this place, so you have to add a 0. So our final answer is 0.09 bar. Or you could also write 0.090 bar. It's the same thing. All right, so why don't you try number 60, and when you come back, we'll do it together. All right, we're back. 1 divided by 12. So this one wasn't too bad. As you can see, it's just bring the decimal straight up, and you have nothing here, so you have to put a 0 for a placeholder. And our final answer is 0.08, and the 3 is barred. All right, so 61. Now 61, something really strange is going to happen. And we're nearing the end of our problems here. I think we just have about 4 or 5 more problems. So let's see what happens with 7. 7 is there's no multiple of 7 that goes into any power of 10, so this is definitely going to be a repeating zero, or repeating decimal. But something really strange is going to happen. Watch this. Remember, you always take the numerator and divide by the denominator. So I'm going to need plenty of room for this one. So 7 does not go into 6, add a 0. 7 goes into 60 8 times. I'm not going to talk, I'm just going to do this so it doesn't take too long. Make sure your numbers are lined up. See how I put that 1 too far to the right. As you can see, these numbers don't seem to be repeating. But we get down to 60, and we saw that that's where we started, 60. So now the numbers are going to start repeating. But let's go a little more here just so you can see what's happening. This problem is hard to show on the page because there's so many numbers. So it goes in 8 times. Bring down a 0. And you can see all the numbers are starting to repeat. And we're pretty much out of room. But what you're going to find is that this number goes, bring up the decimal first of all before I say anything else. This number goes 857142, 857142, 857142, 857142, and it just keeps repeating and repeating and repeating. So the difference for this problem is we have a long string of numbers that we have to put a bar over. 857142, 857142, 8571. So put a big old bar over that entire thing. So why don't you try 62, and when you come back, we'll do it together. In fact, I'm just going to go ahead and do it with you. You can pause the video if you want. So go ahead and try that one. I'll tell you when I'm done so I don't go forward. make sure you have enough room here. And hopefully by that point you can get an idea of what the repeating pattern is, because we don't have enough room to just keep going on forever. Bring the decimal straight up. And if I'm going too fast, just pause the video. I'm going to go ahead and write the answer here. Remember, this is not a race. And there you go. Your pattern is 428571, 428571, 428571. All right, so pause the video if you're still doing that one. And when you come back, we'll go on to the last problems. 7 into 4. Well, why don't you try 63 and 64 on your own, and when you come back, we'll do them together. Actually, I'm just going to do them with you because it's going to take a long time. This helps you with your division algorithm. This is going to apply to a lot of other stuff. All right, so if you're still going with those problems, just pause the video and you can check the answers when you're done. All right, we're back. So why don't you try 65 and 66, and when you're done, we'll do them together. Actually, I'm just going to do them with you like the last two problems. All right. If you're still going with those problems, those were pretty long. So don't feel bad if it's taken a while. It took me a while also. I think I maybe gave you a little bit much to deal with there, but so if you're still going, pause the video. All right, we're back. So for number 65, you should get 0.615384 barred. Make sure the bar is over everything. And number 66, something different happened. We have a 0.3, but that 3 did not repeat. But all the other numbers did repeat. So put the bar over the other numbers. We see it's 571428 and then 571428. So put the bar over 571428. And I'm not going to give you problems that are that difficult probably on the test. I might give you one at the most. So we've got one more thing to do here. We're gonna put mixed numbers into play here. So now we have fractions and we have a whole number. So this decimal is going to change into a mixed number. So first you write the whole number, then you write the fraction. So the number farthest to the right is in the hundredths place. So it's 124 over 100. And you can reduce that fraction, but I'm not going to make you do that right now. So as you can see, it's pretty easy. Just write the whole number and then write the fraction as we've been doing in the previous problems. So why don't you try numbers 68 through 70, and when you're done, we'll come back and do them together. All right, we're back. 56.1. The 56, that's a whole number. The 56 is a whole number. And then the 1 is in the 10th place, so we write 1 over 10. 56 and 1 over 10. 382 is a whole number because the numbers are to the left of the decimal. And then you have 51 over what place is the 1 in? It's tenths, hundredths, thousandths, 10,000ths. 51 over, wait, did I put a decimal there? I'm sorry about that. 51 over 10,000. All right, and we're going to have to move this over a little bit. $23 and 76 over what place is the 6 digits in? Tenths, hundredths, thousandths, 10,000s, 100,000s, millions, 10 millions. So 10 million we need in the denominator. So 23 and 76 10 millions. All right, so now we're going to go backwards. We're going to convert mixed numbers to decimals. All right, so we just write the 3, and then we know it's 7/10, so that's in the tenths place, so we just write 0.7. Very easy. Now, number 72 is going to be more difficult because we have 3/8, which is not as easy to convert, but you're going to have to use long division as usual. So 8 divided into 3. And long story short, you're going to find that it's 0.375. So you write the 6. Actually, I'll write it up here. Write the 6 and then 0.375. So again, you just use long division with 3/8. You turn it into a decimal. Sorry about that. turn it into a decimal using long division like we did before. And then just tack it on to the end as we did here. So it's very easy. All right, so why don't you do 73 through 76, and when you come back, we'll do them together. All right, we're back. So 2 1/5 is 2.2. If you do long division on 1/5, you'll get 0.2. 23 1/6 is 23. And if you do the 1/6, 1 divided by 6 using long division, it's 0.16 bar. Again, we're doing the same thing we did before. We only have whole numbers in front of them. As you can see, this is pretty easy. 718, and then 4 divided by 9. If I do my calculator, I get 0.4 bar. And then 81, 2 divided by 7. I'm doing this just for speed, but you should probably do it on paper. 285714. And bar that, and there you go. So as you can see, mixed numbers are really easy to deal with. You just put the whole number right in front. All right, so that's the end of the work in the class. So now let's go to the homework. Go ahead and take a screenshot of your homework. Take a screenshot of that. Take a screenshot of this. And as you can see, I've written the answers. Check all your answers. Do the homework completely and correctly, or else you can't go on to the next class. So if you made it through all that, I'm proud of you. And I'll look forward to seeing you in class 19. In that class, we're going to be learning operations on decimals, addition, subtraction, multiplication, and division. So I look forward to seeing you then.